Hi, this is Beiling.
And this is Zihao. We're here to present our authoring tool for Maya called Illuminati, which means bright and enlightened. It is based on a SIGGRAPH 2011 paper, a programmable system for artistic volumetric lighting. Here's a working demo of our final image. So you can see all the flowing lighting effects, which is achieved by physical shaders and rendered in 3D light. Here comes more results.
These are the images rendered with our physically accurate shader. You can see the transition of colors between the start color and the end color of the beam. And these are the images rendered with our art-driven shader. Users can define various colors with these shaders.
So our main goal for Illuminati is to provide users an interface to intuitively control the attributes of volumetric lighting effects, both physically accurate and non-physically accurate, and allow the users to customize the volume generation and manipulation. The users only need to manipulate the starting color and the ending color of the curve to get the volumetric effects.
To achieve this goal, this paper uses photon beams to compute surface radiance based on the first radiance equation. It contains four elements such as shown in the second equation. The shading depending on the viewing angle and the beam thickness. Also, the color change due to the attenuation along the beam and towards the eye. In terms of implementation, we use RenderMan shading language to write the shaders, and we use Python ML to write a plugin for volume generation. Also, we use 3D Light as our renderer.
So here is the workflow. The users can begin by generate arbitrary curves. That's duplicated. And hit the button from volume 1. Here comes the curves multiplier. So the shape type controls the cross-section shape of the volume, and users can adjust all these parameters to get the volume that they want. Voila, here comes our volumes. Control them is really simple. You can tweak them, make them twist, or something bigger. Okay, here comes the shading part.
So to assign a shader, we first come to the 3D Light relationship editor. And this is our physically accurate shader. In the attribute editor, we can change the start and end color of the beam. Here we just give them blue and red. Also, we can change the power of the beam, how bright you want a color to be. And now we can hit the render button. Also, we can change the width and length of the beam. This will change the distribution of the color. We can hit render again to see the difference. Next, to assign the art-driven shader, we first come to the art shader shelf, and hitting this button will run the manual code rewrite. This is our art-driven shader. This is a color ramp, and as always, you can change the power, the width, and the length of the beam. But this color ramp provides a more intuitive way to adjust the color. User can change the distribution of the color, can add how many colors they want, and change the color. Now we come to the 3D Light relationship editor to assign the non-physically accurate shader to the object and hit the render button. And this is our result.
And we would like to extend our special thanks to our instructor, Dr. Stephen Lan,
the authors of our paper,
and our friends Zoe, Yuqing, and Stuart. Thank you so much for watching.